In this demonstration video, we will present the tutoring bot, which is a generative chatbot trained with a large scale of tutor-student conversations for language learning. Before we move on to the real-time demonstration, let me briefly talk about the motivation of our approach. When learning a new language, it is difficult to be good at speaking if students don't have enough opportunity to have a real-life practice. Taking it into account, we aim to make a conversational agent that teaches English by having a spoken conversation with students. Our collected dataset consists of dialogues and instructions. Each turn is annotated with the instruction which is used at the turn. The goal of our agent is to teach students English by guiding them to complete all the instructions. Specifically, we aim to enable our dialogue agent to generate responses grounded on each instruction while progressing through all of them in a sequential order without skipping. For this purpose, our agent must be aware of the progress of our tutoring session. In other words, the agent should recognize if the instruction is finished and how many instructions have been completed. On the left side of the screen, we show the overall progress of the lesson and the local progress within the current instruction, which are both predicted by our model.
Hello, good evening. Hi, my name is Jenny. What's your name?
Hello, my name is Kim.
When the session starts, the tutor greets the student by saying hello.
Kim, nice to meet you. How are you today?
Pretty good. Thank you for asking.
Okay, that's good to hear. So, Kim, are you ready for our lesson?
Yes, I'm ready.
In this case, the student failed to say the correct answer. The tutor recognized it and provided the student with a hint for the correct answer.
I want to go to shopping.
Are you sure?
What is the answer?
It should be a place.
I got it. I want to go to France.
Yes, that's right. Okay, next.
As the lesson proceeds, the local progress, which indicates the progress within an instruction, gradually increases toward 100%.
Please complete the sentences again.
Her favorite sport is tennis.
Very good, next.
Messi is the most famous soccer player.
Okay, number.
Nike and Adidas sponsor many promising young athletes.
Athletes, okay, very good. So, Nikki and Adidas.
Yes.
All right, so what do you think is the meaning of sponsors?
When the model judges the lesson and current instruction to be incomplete, it doesn't merely read along the instruction, but it further asks some follow-up questions that can actually engage the student in learning. When the progress of an instruction, the local progress, and that of the whole session, the global progress, are both close to 100%, the tutor wraps up the lesson by saying goodbye to the student.
Okay, so you like to watch him play soccer, right?
Yes, you're right.
All right, thank you so much for your time today, and I hope we can talk again next time.
Me too. See you later.
I hope you have a great day and see you again.
We design progress recognition tasks to endow the model with the awareness of the learning progress. Through local progress recognition task, our model predicts how much progress has been made within an instruction. Also, through global progress recognition task, our model learns how many instructions have been completed within a sequence of instructions. To enable the tutoring bot to provide the student with an educational feedback and make a decision on transition, our model is designed to generate special tokens as action codes which come before the response. First, our model generates confirmation, correction, or others, which we call dialogue action code, as a positive, negative, or neutral feedback on student response. Then, it generates transition token, which we call instruction action code, when the model needs to make a transition to the next instruction. Finally, the response is generated conditioned on these action tokens. Note that we've never predefined the logic that selects a response based on the generated special tokens. In addition to the demonstration, we built a tool to visualize the internal behavior of our model when generating a tutor response. Current instruction and chat history are shown in the left column. When the student submits a response, local and global progress recognition and local and global progress generation results are shown in the right column. The following are some scenarios that clearly show the behavior of our model to control response generation. The student's response, "I want to go to shopping," is grammatically incorrect. The tutoring bot recognizes it and generates correction as the first token. Then the following response asks the student if he or she is sure about the answer. So at the next turn, the student tries again. As the response is correct, our bot generates confirmation token considering it a proper action to take. Then it gives a positive feedback on the student by saying "very good." This scenario shows how our bot makes a transition to the next instruction. As our model proceeds the lesson, it well predicts the increment in the local progress made at each turn. After having some conversation about a country or a place the student wants to visit, our model generates a special token transition. Therefore, our autoregressive model generates a response to move on to the next instruction by conditioning on the transition token. We propose Tutoring Bot, which provides an English lesson through instruction-grounded response generation. To the best of our knowledge, beyond language models for chit-chat, Tutoring Bot is the first instruction-based conversational agent that enables students to experience educational conversation. Through the live demonstrations, we show our bot's ability to generate responses with the awareness of a student's learning progress and proper feedback to provide as a tutor. Due to the limitation of time and computational resources, we've trained our model with some part of our dataset as a testbed, but we'll extend our scope to make our model provide a lesson even when the given instructions are unseen during training. We'll release a public version of our dataset after cleaning and de-identification processes are done.